Look at this challenge before us there. T to the power of 3 equal to 1. What are the three values of t that when we put into this equation will give us 1? Definitely, 1 is one of them. Okay? Positive 1 plus 1 is one of them. But what are the value for the other two? That is the essence of this video. So let's go into today's survey. So here we take our solution. All right. So the first thing we're going to do here is to move this one to this side of the t to the power of 3. So if we do that, it's going to give us our t to the power of 3 minus our 1. This is equal to 0. But remember, 1 could also be written as 1 to the power of 3. So let's write this. This is going to give us t to the power of 3 minus 1 to the power of 3 equal to 0. So with this expression we have here now, what comes to mind is difference of 2 cubes. What does it say? It says that your x to the power of 3 minus your y to the power of 3, this is equal to bracket x minus your y, close bracket, your x to the power of 2 plus your xy plus your y squared. Okay? This is a very special algebraic identity. So if you look at this, what we have here now is synonymous to this. So if we is of the same similarity, then we can rewrite this expression in this format. So rewriting this in this format, this now implies that our t minus 1 close bracket, then bracket open here, then we have t to the power of 2, then plus our t, because here we're going to be t times 1, which is t, then plus our 1 to the power of 2, which is same thing as 1, equal to 0. So we apply a rule that says, so long we are having a multiplication of two quantity here and the right-hand side is 0, then we equate this to 0, we equate this to 0. So we have two cases here now. So we take our case 1. Our case 1, we're going to have here t minus 1, this is equal to 0. So our t1 is equal to, send this to this side we have here to be 1. Okay, so this is what I said earlier on, that many looking at the expression, your t equal to plus 1 is a solution. But how do we get the other two roots? It is clear that the other two roots will give us imaginary roots. But let's go ahead and solve for it. So we're going to take our case 2. Our case 2, we have this, which is our t to the power of 2, then plus our t, then plus r1 equal to 0. Okay. Of course, this is a quadratic equation. So let's solve this using the quadratic formula. So using the quadratic formula, this is going to give us our t is equal to minus b plus minus the square root of our b squared minus 4ac all over 2a. You know that our a is equal to the coefficient of our t, which is a t squared, which is 1, and b is the coefficient of just t, which is also 1, and c is the constant term, which is positive 1 also. So let's just put in 1, 1, 1, 1 in place of this a, b, and c here. So this is going to give us t is equal to minus 1 plus minus the square root of 1 to the power of 2 minus 4 times 1 times 1 all over 2 times 1. So we have t will now be equal to, here we have minus 1 plus minus square root of 1 minus 4 all over 2. Easy, right? Good. So simplify this. This is going to give us our minus 1 plus minus square root of minus 3 all over 2. So we have two solutions from here, this very expression. But before then, look at this minus here, the square root of minus here. We can rewrite this as our minus 1 plus the square root of minus 1 times the square root of positive 3, everything all over 2. So we just have to recall that the square root of minus 1 is equal to our iota. All right? So if the square root of minus 1 is equal to iota, then we can rewrite this expression here. We can put in iota there, right? So let's go ahead and replace this. So this is going to give us our t is equal to minus 1, then plus minus iota root 3. This is all over 2. So let's bring out our two values from here. So we have here, therefore, our t2 will now be equal to minus 1 plus square root, so let's take iota first, iota into the square root of 3 all over our 2, and our t3 is equal to minus 1 minus iota into the square root of 3 all over our 2. Okay, all right, so let's rule out this and this. So these two values and these are the three roots to this third order or third degree polynomial equation. Thank you for being there. See you in our next class.